In this video, I'm going to talk about container problems, and the SAT loves to ask these types of problems in multiple forms. So let's start out with this relatively simple problem where we have 5 boxes that hold 12 pounds of grain and 3 boxes that hold 4 pounds of grain. If we assume that all boxes are full, how many pounds of grain do we have? Okay, so there are two types of boxes that are contributing here. The first is the large boxes, and they hold 12 pounds each. And then we have smaller boxes, and they carry 4 pounds of grain. So the way to figure out the contribution of the large boxes and the small boxes is to multiply the number of boxes you have that are large times 12 and the number that you have that are small times 4. Okay, so let me write that out formally. So the number of large boxes times 12 pounds per one box plus the number of small times 4 pounds per box. Okay, now there's another thing I want to show you in this problem. You see these words, how many? Whenever you see that in a word problem, whatever follows that term, how many or how much, that is what you're going to set your unknown to. So your unknown here, your x, is going to be the total pounds of grain. So all of that is going to equal x. Okay, so if we fill this in, we have 5 large boxes times 12 pounds per box plus 3 small boxes times 4 pounds each. That's going to give us 60 plus 12, or a total of 72 pounds. So when you're doing these container problems, there's 2 issues going on. There is the number of pounds that each box holds and the number of those boxes. That's how you determine the total contribution of each type of box, the large and the small, and then you add them to get the total weight. Continuing on with container problems, if I told you I had 20 boxes and they were either large or small, and I told you that we had 8 large, and I asked you how many small would we have, your answer would be 12. And if I said, how did you get that? Well, what you did was you took the total, which was 20, and you subtracted how many large there were, which was 8, and that yielded 12. Similarly, if I told you we had 10 bags and they were either large or small bags, 7 of them were large, and I asked you how many were small, you would take the total, which is 10, you would subtract the number of large, and that would give you 3. So I want you to use this concept in the following scenario. What if I told you that I had 2 types of boxes? One were large and one were small. Okay, so we have boxes again, and we have 20 total. And for the large boxes, it was unknown. How would you express the number of small boxes? Well, it would be the total minus the number of large. 20 minus x. And that concept, that the total minus the amount of one of the choices yields the number of the other choice, is very important in solving these container problems. Let me give you another one. Let's say we have 50 students in a class. and I told you the number of boys we didn't know, how would you express the number of girls? Well, it would be the total students minus the number of boys. Total minus the other choice gives you the number of the second choice. Now that we've gone through some intuition on container problems, let's look at a couple of examples. I'm going to show these two together at first, and then we're going to look at them individually. So let's look at this black one here. A school has a total of 188 students on a trip. They use buses that hold 12 passengers. I'm going to refer to these as large buses, and buses that hold 8 passengers, small buses. They have a total of 20 buses, and they're all filled to capacity. How many 12-passenger buses were used? See those words, how many? That means we're going to set X equal to the number of 12-passenger buses. Since we don't know, since X is unknown, we have a total of 20 buses. We're going to refer to the number of smaller buses as 20 minus X. Look at this one here. We have a group of 202 people overnight camping, 60 tents. Here the container is a tent. Here the container is a bus. Okay, some of the tents have 2 people each, some of them hold 4 people each. These are our 2 choices. Assuming all the tents were filled, how many of the tents were 2-person tents? How many? Whatever follows those words, how many, how much, that is what you set X equal to. So we're going to set X equal to the number of 2-person tents. Excuse me. We have a total of 60 tents. Therefore, how do we express the number of 4-people tents? It's going to be 60 minus X. So with those 2 hints, why don't you go ahead and try these problems on your own? It's imperative that you try them on your own. Otherwise, this video will not be helpful. Let's look at this blue problem. We have a group of 202 people. Okay, so we know that the total number of people is 202. We have 60 tents. We have 2 types of tents. Large, that hold 4 people, and small, that hold 2 people. We look for these words. How many of the tents were 2-person tents? That's what we're trying to find out. So if we set X equal to the number of 2-person tents, otherwise known as small, then we know, since we have 60 tents, that 60 minus X has to equal the number of large. Okay, now we come up with an expression for the contribution for each type of container. Okay, let's do the large container first. The large container is going to hold 4 people. And how many large do we have? 60 minus X. Plus, the small is going to contribute 2 people per tent, and we have X tents, and that's going to give us a total of 202 people. So 4 people per tent times the number of tents that are large will give us the number of people contributed by the large tents. 2 people per tent times the number of small tents, the tents units would cancel out, gives us the number of people contributed to by the small tents. This is how we're going to solve for X. So we're going to get 240 minus 4X plus 2X equals 202. Negative 2X equals negative 38. x equals 19. And that's going to be choice C. Let's now look at this problem with the black background. We have a school trip that's going to have 188 total students. We have two types of containers. The large container is going to be a big bus which has 12 passengers, 12 students per one bus. And the smaller container is the small bus, which is going to have 8 students for every one bus. Okay, very important. How many 12 passenger buses were used? How many small buses? How many large buses? So we're going to let x equal the number of large buses, which holds 12. Therefore, by definition, if there's a total of 20 buses, 20 minus x has to equal the number of small. Okay, when all the smoke clears, we need to have 188 students. So let's look first at the number of students that are contributed by the large bus. Okay, we are going to have 12 students for each bus, large bus, times x buses, plus 8 students per bus, times 20 minus x buses. And that's going to give us the total number of students. Sorry, I'm misaligned here. Notice, always look at your units. Buses cancel out, students is left. Buses cancel out, students is left. So we're going to have 12x students plus 160 minus 8x students equals 188 students. Okay, once we're sure that our units cancel out, we don't have to write them each time. This is going to simplify to, 1 second, let me just clean this up a little bit. $12x plus 160 minus 8x equals 188. 4x equals 28. X equals 7. So we're going to have 7 large buses, and therefore 20 minus 7, or 13 small. So let's double check our work. 12 passengers times 7 large buses is going to be 7 times 12, plus 13 small times 8 passengers, and this should give us 188. 7 times 12 is 70 plus 14, or 84. 8 times 13 is 80 plus 24, or 104, and that does indeed equal 188. Again, folks, the whole key to this is recognizing that when the unknown is the number of buses, large buses, the total minus x gives you the number of smaller buses.